Okay, now we're going to calculate what the gravitational potential energy is. The gravitational potential energy is the potential energy due to the force which we call the weight. So here's the scenario. Suppose that I have a ball. The way I've drawn it, it's going up, but that's not necessary, whether it's going up or going down. But it starts off at some earlier time at a position y1, and it ends up at a later time at some position y2. The choice of coordinate system here is positive y up. Now, I may have not mentioned this earlier, but from now on I strongly urge you to always choose up to be the direction of increasing coordinate y. The reason is because the value that we're going to derive here for what the gravitational potential energy is will only be correct if y is pointing upward. Okay, so we start off, we have a ball which starts off at y1 and it has a velocity v sub 1, and later we have the same ball now is at a higher altitude, y sub 2, and now it has a velocity v2. And all the while there is a force acting on the object, which is a constant force, which is the one we know how to deal with so far here. And that's simply the weight of this object, which is mg. So there is this distance. This distance is s, okay? And s is equal to y2 minus y1. And the force in the s direction is equal to F sub y, which is equal to minus mg. And so the work which is done on the particle as it goes from y1 to y2 is F sub s times s, which is minus mg times y2 minus y1. And that has to be equal to the change in kinetic energy, which is 1/2 mv2 squared minus 1/2 mv1 squared. Okay. And so now I rewrite this as that 0 is equal to 1/2 mv2 squared minus 1/2 mv1 squared plus mg times y2 minus y1. Now, if you've looked at the previous video, you see that this quantity is what we called u2 minus u1. Okay? And so now we rewrite this as 0 equals 1/2 mv2 squared minus, plus mg y2 minus 1/2 mv1 squared plus mg y1. And so what we see is that the gravitational potential energy, let's call it u sub g of y, is equal to mgy. Okay? In the next video, we'll do a simple example of this. There's one thing which I should point out here, which is that I've done this as if it were a simple one-dimensional problem, but in fact, suppose that the particle was a projectile, and suppose that it started out here and it took some path like this to get up to here. Okay. The work, and I will leave this to you to convince yourself of this, but the work done as this guy goes up here is still minus mg y2 minus y1. Maybe the easiest way to convince yourself is to imagine that there were a path like this, which would be what we just did, okay? And then there was another path like this, okay? During which time there would be no work being done because the force is perpendicular to the displacement. You can make that sort of argument then all the way up here. You can imagine going up like a little sawtooth thing, and each little increment would take you up, and each little sideways increment would not take you up. So no work is done if the object is moving horizontally. Okay, the next videos then will be some examples of gravitational potential energy.